Hello world. So today let's talk about sentiment analysis, and it comes under the field of natural language processing, in which we study how neural networks are going to act upon the text which we are going to feed in. So in sentiment analysis, what we do is we feed in the entire corpus to the neural network, and then we predict whether the sentence present in the whole corpus is positive or negative. So we do sentence by sentence analysis and predict whether the sentence contains anger, or it's happy, or which emotion it's kind of expressing. Right now we'll be using one hot encoding, and so we'll be only telling whether it's sad or it expresses happiness. And so let's learn how you can implement it practically. So first of all, I'll using this GPU NVIDIA Tesla KT on Amazon AWS. So if you have access to that, you should really go for it, because we'll be training our neural networks, and in the end I'll be making use of LSTMs also, which we haven't talked about earlier, but I'll be covering that in my later topics. So make sure you have access to a CUDA GPU, otherwise it would take a lot of amount of time to train your neural networks. So first of all, we are going to import this CUDA library. Then I'll be giving the link to the repository in the description section. So this utils, it's a helper function module which I've created, and I'll be picking up modules from this program. So I'll be giving you the link to the GitHub repository, so make sure you check that. Then we'll be making use of this IMDb model, and it's very easy to get this dataset, and it's already included in Keras library, so there is no difficulty in getting it. Then we're going to import this library from Keras.datasets, and then we are going to arrange the indexes. So words are not mapped as you would think in a corpus, and every word is associated with an ID over here, and all these IDs are encapsulated in a vector. So what I did is, first of all, we created this variable index to word, which gives a word from the index which we are going to search. Then we set the vocabulary size. So this vocabulary size is the number of words which our network is going to retain, different words. And then we make sure how many elements are there in an array, NumPy array, and then we create sequence length of sequences which are going to create. Then we make sure it's an assertion by the shim module, and then we create a single hidden layer. Note that we'll be trying to beat what has been discussed in this paper. So this paper was published by Stanford University, and in this paper they reached over an accuracy of 88.33, and we'll be beating that. And when I trained my neural network, I received an accuracy of over 90%, which means we did really good. And so what we do is, first of all, for demonstration purpose, we create a single hidden layer. So since it's a single hidden layer, you don't need to expect so much from it. So we'll be creating a sequential layer, and then just putting in the IDs into your neural network isn't going to make much sense. We'll be using a embedding layer, and then we are going to flatten it. So flatten itself doesn't do anything, just it's going to reduce the dimensions. And then we set the number of filters, and then we specify the activation function which we are going to use, which is in this case ReLU, and it's the most preferred activation function if you are using it in between layers, right? And then we set the dropout. So it's as I've discussed, regularization method. I made a video on how you can prevent overfitting, and I have discussed all these in details. And then again you set a dense layer, linear dense layer, and then since our output is going to be binary, so we use sigmoid function. And so since we have used a sigmoid function, our output is going to be binary, and so the loss function which we are going to use is binary cross entropy. You can also use categorical cross entropy also, but in this case binary cross entropy is much more advisable. And the optimizer which we are going to use is ADAM, which makes use of RMS prop and gradient descending momentum. So, and then we use model.summary to just evaluate how our neural network has been created. So first of all, flattening layer we use flattening module, and then we created a dense layer, then we use dropout. So which means we are using a dropout of 0.7, which means we are using only 70% of the activations. So we are removing 30% of the activations so that our model doesn't overfit. And then we are going to train our neural network model.fit, and then we are specify the validation dataset and number of epochs. So I'm going to train my network for 2 epochs for the entire dataset. Then we've set the batch size, which is in this case 64, and then the accuracy which we achieved is 76.64 in this case, and in this case it's 92.92. So the validation accuracy over here is 87.67%, and over here they have achieved an accuracy of 88.3. so we are not so far, and it means we are going to the right path. It's an indication. Then we use single convolutional layer with max pooling. So again we create the sequential layer over here, then we use embedding, then we set the vocab size which was equal to 5000. Then we are going to use dropout in embedding layer, and then again we use dropout. Then we create a convolution layer, then we set the activation function which we are going to use. Again we use dropout in order to prevent overfitting. Then we use max pooling. So if you have, we don't need to go in much detail, but for just help purpose, max pooling, what it does is, if you are using max pooling, it reduces the number of elements in your matrices. It's going to reduce it, so it always takes the higher value over here. So in this semi-matrix submatrix you have 1 0 4 6 as its element, so 6 is the dominant value over here. So in the max pooling layer 6 is going to predominate, and similarly it does all that with matrices as well. So after we use max pooling, we are creating a flattened dense layer, then dropout, then again dense layer, and then we specify the loss function which we are going to use. Then we specify the optimizer ADAM, and then we use model.summary to visualize how our neural networks been created, and these are the total number of parameters in our neural network. Then we fit it, and the accuracy which we are getting is 89.37, and we are not that, and I think yeah, we have surpassed what they have achieved. So it was 88.33 here over here, and we have achieved a validation accuracy of 89.37, and we have already surpassed what they have achieved. And note that this is a single convolutional layer with max pooling. We haven't done anything extra. So with all these simple layers you can achieve state-of-the-art results. Then we save. Don't forget to save your model. It's going to save your computational power also. You don't need to recalculate everything. Just save the model, and you can just use this load weights module, and it's going to load the weights of your neural network, and you can just use all these weights, and then you can fine-tune your model to create or apply it somewhere else. So I hope you have gathered a fair idea of how you need to go about sentiment analysis, and how you can create a simple model which achieves good results. I'll be adding more to this playlist natural language processing over here. Feel free to check out other videos which are made on generative adversarial networks, recurrent neural networks, and convolutional neural networks. And please hit the like button, please subscribe to my channel. I'll be adding more stuff related to MLDL and computer vision NLP. Thank you.